Hello, this is question 3 on your June 2019 paper, statistics paper from Edexcel. Barbara is investigating the relationship between average income, GDP per capita in dollars, so is the variable X, and the average annual carbon dioxide CO2 emissions in tons for different countries. She takes a random sample of 24 countries and finds the product moment correlation coefficient, this one. Stating your hypothesis clearly, we have to test at 5% level of significance whether or not the product moment correlation coefficient is greater than 0. So our hypotheses are going to be H0, always the coefficient 0, and H1, we are checking if there is a positive, is greater than 0, yeah? So the H1 is going to be positive. Level of significance is 5%, the observed value we say is 0.446, and C has tested 24 regions. So we are going to write the critical region using the tables in the formula booklet. So this is the table for the critical values of correlation coefficients. N is 24 and the significant level is 5%. So we are talking about this value here. This is my critical value. I don't know if you can see. 0.3438, which means my critical region is when R is greater than 0.3438. The observed value is this one. So it falls in the critical region. Yeah, it's greater than this value here. So my observed value is in the critical region, which means I'm going to reject H0, therefore accept H1. And you should write a line, a conclusion saying that there is enough evidence, something like this, enough evidence to support Barbara's claim, or that there is no positive correlation, yeah, either way. Then for B, they say, Barbara believes that a non-linear model would be a better fit for the data. She codes the data using this coding and obtains this line of best fit. The product moment correlation coefficient between C and M is 0.882. So what is happening is that we have the connection, just to explain you briefly. So we have a connection between X and Y. That was the average income and the annual carbon dioxide. We have our points in a scatter graph. We know it's positive, but it's not really linear. So we code those values doing this change of variable, and when we represent M and C, we get a much better line of best fit. So our points are really more in a line. And this is the line of best fit that we get here. When we have the line of best fit, we have a connection between log M or log X and log Y. If we undo the change, we will have a connection between X and Y. That is not going to be linear. Yeah, it's going to be in this form. So this is what we are doing when we do this change of variable. So it says, explain how this value, so this one, the product moment correlation coefficient between C and M, supports Barbara's belief. So it's very close to 1, so it's 0.882, so it's a high value. It's a high product moment correlation coefficient, which means there is linear correlation. That's what C correlation. That's what C is assuming. Yeah. Then for C, it says show that the relationship between C, Y and X can be written in this form. So we have a connection between C and M that are really log X and log Y. So we are going to work with logs until we write Y in terms of X, yeah? Eliminating the logs. So our line of best fit is C equal minus 1.82 plus 0.8 0.89, but this is with the coded values. And remember, C was log x, no, log y, no? C is log y, and M is log x. So I can put together the logs. So I'm going to write in the next. I'm going to subtract this in both sides. So I have log y minus 0.89 log x. It was minus 1.82. I'm going to put this together using the properties of the logs. So this can go to the exponent, and I have minus, so I'm going to divide both things. Well, I can do it in 2 steps just in case. Minus log 10x to the power of 0.89 is going to be minus 1.82. And now properties of the logs again. I have y divided by x to the power of 0.89, and this is equal to minus 182, which means that y divided by x to the power of 0.89 is going to be 10, because it's my base, to the power of minus 1.82. Therefore, y is 10 to the power of minus 1.82 times x to the power of 0.89. And now we have our equation in the way that we need it. So this is the constant, they call it a, and the exponent is n, and we have to find that a and n, and this is n. So we can say that a is 10 to the power of minus 1.82, which is 0.0151 something else. So I'm going to leave, for example, 3 decimals, and n is going to be 0.89. Yeah, and that's what they ask, a and n, really, or write the relation in that way, no? A and n are constant to be found. Yeah, so that's it with this exam question.